We're going to work on probabilities using the normal curve. I'm working on the Chapter 6 worksheet, and I'm going to work through number 4. It's really difficult to read what I've got printed here, so you can print out your own copy, but I'll also put up the important information here. It says, according to the Bureau of Labor and Statistics, the mean RN salary, so registered nurse salary, in the state of Washington is $73,000. So let me write this down. So the mean is $73,680 with a standard deviation of $12,784. And then it says, if a registered nurse from the state of Washington is selected at random, compute the probabilities. Well, because we're in Chapter 6, we're assuming that this variable, which is nursing salaries in the state of Washington, is normally distributed. I'm going to give myself a couple of scales here. These are my raw scores. These are my z-scores. The mean always falls in the middle if it's normally distributed. So this is 73,680. And the z-score of the mean is always 0. So this is what my initial setup looks like. The 12,000 would give me 1 standard deviation above and then 1 standard deviation below if I subtracted that 12,784. Okay, so that's the setup. The first question, so part A, is looking for the probability that the salary of this randomly selected person is between 65,000 and 75,000. In the last video, we looked at binomial probabilities because we were counting things and that was discrete, but salary is a continuous variable. I can have, spell that right? I can have 65,000, I can have $65,182.93. We consider that to be continuous, so there's no 0.5 adjustment. So we're not going to do that 0.5 adjustment that we did for the binomials, which means it's a little bit easier. So what I really want to do then is to figure out where my 65,000 lives and where my 75,000 lives on my z-score scale. So I'm going to figure out the z-score for 65,000. So 65,000 minus 73,680 divided by 12,784. So I'm going to go ahead and put that into the calculator. 65,000 minus 73,680 divided by 12784, and I end up with negative point, let's call that negative 0.68. So this is negative 0.68. So on my scale here, negative 0.68, I'm about right here, so that would be negative 0.68. This is 65,000, so it lives right there. I'm going to do the same thing for 75,000. So the z-score for 75,000, everything's going to be the same as my last calculation, except that very first number. So in my calculator, I can actually just arrow up to my entry, hit enter, and then back up to where I put in the 65, change it to 75. Isn't that slick? Hit enter. And I've got a z-score of about 0.10. So 0.10, 0.1 is going to be really close to 0 here. So there's 0.1, and that's for 75,000. So I'm looking at this band which is here. Can you see that with the yellow? So I'm looking at this band, this area right here. That's going to be my probability. So as I figure out the probability, I've now changed this so that I can use the calculator's normal curve. Okay, 75. This is equal to the area of z-scores between negative 0.68 and 0.10. So I can just go ahead and in my calculator go to the distribution menu. Did you see how I got there? Let me do it one more time. I go to the distribution menu, which is right here. I'm going to pick normal CDF. I'm going to accumulate for C, the area. My lower z-score is negative 0.68. My upper z-score is 0.10. I'm using z-scores, so I do want a 0 and a 1 for the mu and standard deviation. I hit paste and enter, and I end up with an area of about 0.2916 or 29.16%. If you were doing this on the other calculator, it's going to be really similar, but I go to my distribution menu. When I choose normal CDF, that's all that shows up on the screen, but it's always low, comma, high, so negative 0.68, comma, 0.1, parentheses, and I get the very same answer, 0.2916. There is another way that you can do this. I do want you to be able to convert to z-scores like we did here, but I would not be being fair if I didn't show you the other way. I'm going to pull the older operating system off for a second, and I'm going to do it the other way. So using the same information, I'm going to go directly to, say I hadn't computed z-scores. I go directly to my normal CDF. This is the newer operating system. I'm going to show you the older one in a second. And instead, I'm going to use for my lower raw score, which is 65,000, which is my salary. So 65,000, I've got way too many zeros there. 65,000. Upper is 75,000, but since I'm using raw scores now, I need to type in my mean raw score, which is 73,680, and then my standard deviation raw score, which is 12,784, and then I hit paste. Before I hit enter, take a look at what my calculator enters. It enters, let me back up, a normal CDF. Okay, so it starts with the lower, comma, the upper, comma, the mean, comma, the standard deviation. So if you have the other operating system, I'm going to hit enter. You can still do it. I'm going to write the order down on the calculator. So this is normal CDF. Low, high, mean, standard deviation. This is if you're using X's. Okay, so low X, high X, your mean and your standard deviation. Okay, we got the same answer, very, very close to the same answer. So let's go ahead and put that into, I rounded, by the way, which is why we got slightly different answers, but we're close enough. So let me go ahead and put this also into the other calculator. Okay, there's the answer. When I say I rounded my z-scores, which is why there's a slight difference. So if I do this again, I go normal CDF. I type in my lower salary. These are my raw scores, comma, my upper salary, comma, the mean, 73680, comma, the standard deviation, 12784. And then I hit enter. And again, it's slightly different, and that's because I rounded my z-scores. So be really careful if you're using this, say, in Connect Math. Connect Math is really specific, and it will say round intermediate calculations to a certain number, which means since there's no rounding in the second version, it's doing everything all at once, your answers might be slightly different. But for the midterm, it's a great way to double check, a great way to get to your answer. We get a slightly different answer of 0.2925, which is 29.25%. Okay, that's part A. You've got two different ways to compute it. I want to take a look at part B next. Part B says more than 90,000. So if we take a look at part B, so for part B, we want the probability that the salary is more than 90,000. Okay, again, we don't need the continuity adjustment. I could do the z-score method, so I could do 90,000, and I would go ahead and set that up exactly like I had done up above. I'm just going to get you started on this one. So I can compute it this way, or I can go back and I can use that normal CDF by typing in the mean and standard deviation. I'm going to use the older operating system. Normal CDF, low is 90,000. Oh, there's no comma there, 90,000. The high one, well, it goes on forever. I don't have a high one, so let's just type in a huge number, like a whole bunch of zeros after that. Comma, I'm going to see if it likes this or not, comma, 73,680, comma, 12,784, parentheses. Okay, and we get, this is for the probability, 0.1009. Okay, remember we typed in just a huge number for that upper. Let's go ahead and actually do the z-score and figure it out that way. So that z-score, if I go ahead and do that calculation, is 90,000 minus 73,680 divided by 12,784. So the z-score for 90,000 is 1.277. Okay, here's my normal curve. There's 0. 1.277 is like about right here. And this is where 90,000 lives. 1.277. So really what I need to do is just to take the area. Where's my yellow pen? I want this area here. So I'm going to go ahead and do my normal CDF. I'm just going to do this right into the calculator. Normal CDF. Low is 1.277, comma, high. I'm just going to pick a large-ish z-score. 12 is huge in terms of z-scores. Close parentheses, which means I'm assuming that I'm on the z-score scale. 0 for my mean, 1 for my standard deviation, and I hit enter. And there's that same value. It's just slightly different, right? But do you see them both up there? It's good enough. Actually, it's very good. So I get 0.1008. Okay, other calculator, just to make sure everyone's got everything they need. If I do the same calculation on this one, this is the newer operating system. It's going to ask me for the lower, 1.277. The upper, I just pick a large-ish z-score. My mean, I'm using z-score, so I've got to set my mean back to 0. I'm using z-score, so I use a standard deviation of 1, and then I hit enter. Enter. And there's that same value. So you've got a couple of different tools here, but do make sure, even though we've got these great tools with the calculator, that you can also compute the z-score and then find the area that way.